Hey everyone, it's Dr. Jess. Welcome and welcome back to my channel. In today's video, we're going to discuss strong, weak electrolytes and non-electrolytes. If you like these types of videos, please don't forget to like the video, subscribe to my channel, and turn on your notification bell so you don't miss out on any new uploaded videos. Okay, let's get started. What are electrolytes and how do we differentiate between strong electrolytes and weak electrolytes? So when electrolytes dissolve in water, they separate into ions and their solution conduct electricity. Now, for strong electrolytes, when they dissolve in water, they dissociate completely into ions. So 100% dissociation. So what does that look like? So some examples of strong electrolytes are, for example, ionic compounds such as sodium chloride. So when sodium chloride dissolves in water, it dissociates completely into sodium ions and chloride ions. So completely Na plus and Cl minus. Potassium bromide, same thing, K plus and Br minus. Bases such as sodium hydroxide are also strong electrolytes, so fully dissociate into Na plus and OH minus. Acids such as hydrochloric acid fully dissociate into H plus and Cl minus. Now, for weak electrolytes, when they dissolve in water, they dissociate partially. So unlike strong electrolytes which dissociate completely. So what does that look like for weak electrolytes? So let's take the example of hydrofluoric acid, which is a weak electrolyte, HF. So when HF dissolves in water, so you'll have some dissociation into H plus ions and F minus ions. Then as more of these ions are forming, some of them will then recombine into HF molecules. So in that solution, you'll see ions and also molecules, which is different from strong electrolytes. When strong electrolytes dissolve in water, in that solution, you'll see only ions as the type of particles. But with weak electrolytes, you'll see ions and molecules. So some other examples of weak electrolytes, ammonia is an example, acetic acid is another example. So they dissolve partially. Now, let's talk about non-electrolytes. When non-electrolytes dissolve in water, they do not separate into ions and their solution do not conduct electricity. So an example of a non-electrolyte, the carbon compound, methanol, ethanol, they're non-electrolytes. So in a solution like that, so all you'll see is molecules of the compound, so molecules of methanol. They do not dissociate at all. Now let's look at some examples and see if we're able to identify them either as strong electrolyte, weak electrolyte, or non-electrolyte. So the first example is sodium sulfate, Na2SO4. So what do you think? Do you think this is a strong electrolyte, a weak electrolyte, or a non-electrolyte? Type your answer right now in the comment. I'll give you 5 seconds to type either strong electrolyte, weak electrolyte, or non-electrolyte. 5 seconds. Okay, if you typed strong, then you are correct. So sodium sulfate is a strong electrolyte. When it dissolves in water, it dissociates completely into sodium ions, so Na2 plus, and sulfate ions, SO4 2 minus. So it is a strong electrolyte. Now let's look at the second one, hydrofluoric acid. We talked about that one previously, HF. We said that it is a weak electrolyte, so partial dissociation. The last one, methanol, is a non-electrolyte. So when dissolves in water, it does not dissociate. Now, type some other examples of strong electrolytes that you know of in the comments below. Type as many strong electrolytes that you know of in the comments below. Okay, that's it for today. Please don't forget to like, subscribe, and turn on your notification bell on your way out. I'll see you in the next one. Bye.